Okay, so the question was asked about this whole question of whether we should include the dad or not. In the not dad model, we basically had an extra edge representing the mystery dad. And we could, of course, put an explicit random variable representing the genetic state of mystery dad. And here I've proposed a hidden variable new, looks like a little v, representing mystery dad. And then I just kind of go through the math here. Okay, what would the likelihood work out to be for inheriting the SNP from mystery dad? So you recall this idea of explicitly including mystery dad is being offered here as a counterpoint to this not dad model where we just directly drew an edge from theta to lambda, where basically we're saying lambda inherits two copies of the chromosome, one from mom with probability mu over 2 of getting the SNP, and then another copy from basically the population allele frequency theta, basically what's the probability of inheriting the SNP on that copy? It's just theta, right? Under this model here where we're just directly drawing the edge from theta to lambda. Okay, well what if we, instead of doing this, we stick in a hidden variable representing mystery dad, we call that new, and it goes in there right on that intervening edge going from theta to lambda, right? Just like mu is there in between theta and lambda. Well, of course, we can do that. And if we do that, we can run through the math for what we're going to get. So, again, getting one copy from mystery dad, the probability of getting the SNP on that one copy is just mu over 2, just like it was for getting the SNP from the one copy we inherit from mom. And of course, we also have to consider the probability of getting a particular value of mu given theta. You run through the math, a couple terms cancel, and you just get exactly the same thing as if you hadn't included mystery dad. So this is really what I mean when I say that a random variable is irrelevant to an information graph structure or to a scoring function, basically because it does not change the likelihoods of the observables. There's no difference. Whether we include mystery dad or we don't include mystery dad, we get exactly the same thing. Okay? So you consider that to be really the test then for whether a particular random variable is relevant or not to your model. If it doesn't change the likelihood of your observables, it's not relevant. Any questions about this principle? Okay, so you know, if we apply this principle to other things in this picture, such as our variables like, you know, the genetic state of the mother and child, we really would not find that they're unimportant. In other words, you know, they really affect the likelihood, so we can't get rid of them. All right. So let's see. We can apply this same kind of thinking to the hidden state variable just for the child. And this gets back to what I told you a few days ago about this single peak rule. In other words, the fact that the likelihood for our observable C has multiple peaks. Each one of those peaks reflects a different value of lambda, right? So when we see that kind of a pattern, basically this is telling us that even if we try to get rid of lambda from the information graph, either, two things are going to happen. Either we're going to end up getting the likelihood for our observable wrong, because we're trying to put too many complications together into one likelihood function, and the probability of getting it wrong, of being able to can you correctly weight these three peaks, or do you even realize that there are three peaks there? If you're not considering lambda, that's easy to get wrong. If you get it right, then you haven't really gotten rid of lambda, right? It's just hiding there on that edge, and you're pretending that one edge, is a single model when it's actually three different peaks. So I would definitely recommend, for both of those reasons, that we definitely should keep the single peak rule, and that justifies why we need to keep the child's genetic state lambda in this information graph structure in this model. Any questions about that? Okay, well, let's